Hey, welcome back. Today we're going to learn about the most basic type of sequence, I think, which is an arithmetic sequence. So, an arithmetic sequence is any sequence that the terms go up or down by the same thing each time. We say that what it goes up by each time is called the common difference. And so in this first sequence, 5, 8, 11, 14, every single time you're simply adding 3, right? 8 plus 3 is 11, and 11 plus 3 is 14. And so the next numbers in the sequence would be what? 17 and 20 and 23. So that's an arithmetic sequence. We call this amount that it goes up by each time the common difference. And in this case, it wasn't too hard to reason out what that was, but in general, you can find the common difference by doing a subtraction. You take a term and you subtract the term right before it, and that's the common difference. Common difference doesn't have to be a positive number. So in this example down here, to go from 9 to negative 2, that's a decrease of 11. And notice if we do that again, subtracting 11 more, we get to negative 13 and then negative 24 and so forth. So that's an arithmetic sequence. Now, the general formula for an arithmetic sequence is something you should memorize. The general formula is to start with the first term, and then you add whatever that common difference is times n minus 1. I want you to I hope notice that this is very similar to y equals mx plus b. So your values are equal to your starting value, your beginning, your b value, and then d really acts a lot like a slope. So I like to memorize it like this. I call this my template for building an arithmetic sequence. I need to put the first number here, and I need to know what the difference is here. And then my formula will have an n in it. Sometimes it's helpful to multiply this out and distribute it and clean it up a little bit. And sometimes you don't really need to bother. But that's definitely a formula worth memorizing. Let's see this in action. So here is a simple sequence, negative 4, negative 1, 2, and 5. And the first thing I want to do is see if I can figure out what that common difference is, see if this really is an arithmetic sequence. And so the first couple terms here seem to be increasing by 3 each time. And so 3 would be our common difference. And that means if we wanted to find the next couple of terms, that's simple enough. We'll just continue to add 3. And so 5 plus 3 would be 8, and then 11 and 14. And that works good. That's called recursive thinking. And if all I needed to do was find the next couple terms, that would be great. But one of the questions that we have to deal with today is what's the 47th term? And that would not be an easy one to find with recursive thinking. Or another question, where does 491 fall on this list? Neither of those works very good with recursive thinking. We really want a formula for the nth term. So to find the formula for the nth term, let me bring out our little formula builder here. In this, I need to put the first number in the list here. And so that would be the negative 4 that we've got. And I'll put the common difference here, and that's the 3 that we found earlier. And we could leave our answer like this, but it might be a little bit easier to work with if we distribute the 3 to both of those terms and combine like terms. So here's a slightly nicer looking version, I think, for this formula. And so if I wanted to find the 47th term in this list, then I put in a 47 for n. So the 47th term is 3 times 47 minus 7. And I'll just get out a calculator a moment, see what that is. 3 times 47 minus 7 is 134. The last question in here, where does 491 fall on this list? So in this case, I don't know what n is, but I know that I want a 491. And so I would take my formula, set it equal to 491, and see what we get. In this case, if we add 7 to both sides and divide by 3, 498 divided by 3 gives us 166. And so 491 would be the 166th term in our list. Here's another example. In this case, we want to build a sequence so that it has as its 19th number 42. And I also want the common difference each time to be negative 2/3. And so the question is, well, what's the first term in that list? And in general, what's the formula for the nth term? So let me bring in a table a moment and just kind of fill in some of the things that we know. I know that I want the 19th number in the list to be 42. And the common difference of negative 2/3 means every time I go forward a step, so 20th term would be 42 minus 2/3, which would be 41 1/3. And the next number in the list would be another 2/3 subtracted from that, so that would be 40 2/3, and 22 would be back down to 40. And so what I need to do is kind of work my way backwards in this list and figure out what the first number in this list is. And you could add a bunch of 2/3 to go backwards in this list until we get to 1. I'm going to try to be a little smarter than that. Instead of going all those, let's see how many times I'd have to add. I have to add 1, 2, 3. I'd have to go from 19 to 1, so that's 18 steps. And so 18 times 2/3 is what I'd have to add. So let's do 18 times 2/3. So 18 times 2/3, that's 36/3. So 42 plus 36/3. 36/3 is 12. So 42 plus 12 is a 54. So first number in this list should be 54. Now that I know what the first number in the list is and what the common difference is, I can write my formula. And so I need to put my 54 here. And I need to make this minus 2/3. And so there is a perfectly good formula. And if you wanted to, you could distribute this and combine like terms. I think I'm just going to leave it as is. I think that's good enough for this problem. All right, one last example. So this time I want to build a formula so that the fifth number in the list is 20 and the 21st number in this list is 16. So if I wanted to visualize what this is a moment, the fifth number in the list is 20 and the 6th, 7th, 8th, 9th, I don't know what all those are, but eventually the 21st number in this list is 16. And I'd like to know what the first number in this list is so that I can write a formula for it, but I got some work to do to make that happen. What I really need to do is, well, here's my formula. Here's what I need. I need the first number in the list. I don't have that. And I need the difference. I don't have that either. So the common difference, how much do I have to go, looks like down by each time so that after that many steps, I've gone from 20 to 16. Well, here's a little trick. We said earlier that these are kind of like y equals mx plus b. That means the difference is a lot like our slope. And so we can find the common difference by using a variation of the slope formula. So here is the common difference is equal to the change in our sequence values, like 20 to 16, divided by the change in n. That's just like slope, change in y over change in x. And so let's see if we can find that in a moment. The change in the sequence numbers is, I wanted to go from 20 to 16, so I'm going to type the final minus initial, 16 minus 20. And I want the change in n, so I'll do 21 minus 5. And that gives us the fraction negative 4 on top of 16. And that reduces to what, negative 1/4? And so let's put in a negative 1/4 for our common difference here. And now we need to figure out what the first number in this list is. And so here it might be fastest just to backtrack a couple of times. I'm sure I could write a formula for how many steps this is like I did last time, but I only have to go 4 steps. And so subtracting can be easier here too. So let's see, if I go backwards on the list, I'm adding 1/4 each time. So this would be 20.25 and 20.5, 20.75, and this would be 21. So here's a formula, 21 plus -1/4 times n minus 1. So let's see if this formula is correct by simply taking a moment and plugging a 5 in for n and a 21 in for n and see if it gives us what we would expect. So if we put in a 5 for n, then 5 minus 1 is 4. And 1/4 of 4 is 1, and so we've got 21 minus 1, which does in fact give us a 20. That's a good sign. Now let's try plugging in a 21 for n. And so if I plug a 21 in for n, 21 minus 1 is 20, and 1/4 of 20 is 5, and so I've got 21 minus 5, which does in fact give me the 16 that I would expect. So there's a couple examples of creating formulas for arithmetic sequences and using them. Come back for the next video where we figure out how to add up numbers in an arithmetic sequence.